Question 4.2 here, we're dealing with the binomial probability distribution this time. So here it gives us that there's a 40% chance that any given student in the class will get a B for their grade, and you're randomly selecting 5 students, and we want to construct the binomial probability distribution after verifying first of all that it's binomial, and then find the mean, variance, and standard deviation. So remember, for it to be a binomial distribution, just like it says in the book, you have to have various criteria, one of which is that it has to have a success and failure. So in other words, in this case, it's either that they get a B or they don't. And then we also have that the probability has to be the same for your success every time, which is 40% or 0.4 as a decimal. And then the probability of failure, remember, is 1 minus that probability of success. So it'd be 0.6 as a decimal, or 60%. And you want to make sure to verify that all of the properties are there as well, which all of them are satisfied in this case. Just something to keep in mind, especially if you're working on ones on a quiz or test. To verify, make sure everything is satisfied in order for it to be a binomial distribution. For most of them on quizzes or tests, it'll be either this binomial or one of the other two that we'll be talking about in section 4.3, which are called your geometric and Poisson. So here for this particular one, so again, it's just counting the number of successes. So the 0, 1, 2, 3, 4, and 5 here represents how many successes there are in this case of if they got a B or not. So a success in this case is that they got a B. A failure in this case is that they got something else, is how it's defined for this particular problem. So here, to find these, remember what we're doing here. So we have our formula. We're using our combination formula. So in this case, the first one, we have 5 students that were selected. Then combination, 0 successes, times, and then we do our 0.4, which is probability of success. In this case, there are no successes, so we'd have 0 for the exponent, times, and then we get 0.6 to the 5th power. Remember, for your failure, probability of failure, since our probability of success P is 0.4, probability of failure, which is denoted as Q in your book, is 1 minus P, which is how we got the 0.6. And then if we go through and calculate that, remember, you will need to remember how to do these in terms of the factorials as well. Just going to write it for the first one here to save on time. For the video, we'll have 5 factorial over, then we'd have 5 minus 0 factorial times 0 factorial for the formula there. Let's remember how you denote this. Remember, it's n is the first number, which goes on the top with the factorial, and then x goes in the bottom with 5 minus the x, which is 0, times x factorial, which is 0 in this case. Or sometimes it's called NCR, is what we used before for this notation. So for that first one there, let's type it in here. Should get approximately 0.07776 for the first one. For the next one, we do same sort of thing again. We have 5, this time C1, since we want 1 success. Remember, the numbering here represents the number of successes, which in this case is getting a B, times 0.4 to the first, so the probability of success, and then however many successes in the exponent, times, and then the probability of failure, and then how many failures there are in that case. So if there's 1 success, that means there's 4 failures, since there were 5 students altogether that were included in this particular calculation for this problem. So if you go through and calculate that here, you should get about 0.2592. Make sure, like normal, that you're double checking, seeing if you get the same answer. If you get something else, you can always come in and double check with me, or you can check in class if you're not sure if you're doing it right, perhaps, or how to plug that into your calculator. But some of yours, you'll have to go through and do this combination stuff by hand, since not everyone's calculator is going to have the same features here. So for the next one, we want 2 successes, so we'd have 0.4 to the 2, and then 0.6 to the 3. So that way we have a total of 5. 2 of them are successes, 3 of them are failures in this case. So remember, failure does not, in this case, mean that they failed the class, just means that they didn't get a B. So it could be maybe that they got an A instead of a B there. All depends on how the problem is defined in terms of what these numbers are representing. Here for the next one, we'd have 5C3, 3 successes in this case, so we'd have 0.4 to the 3rd. And you will need to remember this formula and how to use it for your tests and quizzes. And then 0.6 to the 2nd power, so 0.4 to the 3 there, and 0.6 to the 2nd. Make that 3 look a little bit nicer there. Alright, and then whenever you calculate that there, you should get about 0.2304 for that one. And then for the next one there, we're looking at 4 successes, so we'd have 5C4 times 0.4 to the 4th power times 0.6 to the 1. Because if there's 4 successes, that means there's 1 failure in that case. So if you go through and calculate that out there, you should get about 0.0768 for that one. And then for 5 successes here, we'd have 5C5 times 0.4 to the 5th power, since we want 5 successes there, and no failures. Keep in mind, once again, if you have something to the 0 power, or if you have a 0 factorial, those are equal to 1, not equal to 0 like you have if you multiply. Exponents and the factorials are different. If you have a number to the 0 factorial, that value is equal to 1. That's to keep in mind there. So for that last one there, you should get about 0.01024. That's in terms of your probability distribution for this binomial case. And then to find your mean, variance, and standard deviation here, we have a little shortcut that we can use. Whenever we're dealing with the mean, it's going to be equal to your n times p, where n is the number of people that we're talking about. In this case, we had 5 students, and then the probability of success is your p again. So here in this case, we'd have 5 times 0.4. So if we calculate that out there, we get 2. For our variance, what we have is we have our n times p times q, all of those multiplied together. So here we'd have 5 times 0.4 times 0.6. So if we multiply that out there, we get 1.2. And then for the last one there, we have to go through. Remember, for the standard deviation, that's the same as the square root of our variance. So there we have to do the square root of our n times p times q. Or you can just write that as the square root of 1.2 there. So if we go through and calculate that here, get approximately, And remember here, whenever you're plugging these in, depending on your calculator, depends on exactly how you plug these in. Some of you will have to plug in the 1.2 first and then the square root. Some will have the square root and then the number there. We should get about 1.095. That would be in terms of finding your standard deviation there. So once again, you can use these shortcuts for the mean, variance, and standard deviation whenever you have a binomial case. So if you look back at what we had in section 4.1, it's a much quicker process than what we had for an original probability distribution in general. Much shorter process for the binomial case. So if you can identify it as binomial like we have here in section 4.2, that can make finding those mean, variance, and standard deviation a lot quicker.